Hello everyone, welcome again to my channel. So today in this video I will talk about pre-order traversal of a tree. In the previous video I have discussed all the three kind of traversal, that is pre-order, in-order and post-order. So in this video especially I will talk about pre-order traversal. We will do the coding, so iterative way and both recursion way. Okay, so do a recap kind of thing. So what is pre-order traversal? So pre-order traversal means DLR. This rule you have to follow. First we will visit the parent node, then left side, and then we will go to right side. So D will be denoted as parent, left side will be L, and R is the right side child. So if any case or any point of time, if we have any confusion, like how we are traversing or we lost track, so the good thing to do is we can denote all the nodes as DLR. Then what we can do is first letter here we will take, that is D. D means the root node or the parent node. So I will print that thing. Then we will check for L. L will move to left side. So after coming here, we will check the D and we will print 2. Then we will check for the L. We will go here and here also we will check for D. 4 will print. Then L, nothing is there, null, nothing will print. R also nothing is there. This part is done. We will come back here, go to R. Here we will take for the D, we will print here, left and right both are null, so all are done now. So we'll come back here and we can check R is present here. That means we have to go to right side. So we'll mark it here and go to right, and here also we'll apply DLR. So D means the parent will print 3. Then we'll go to L, left side. We'll come here, D will print, that is 6. Then L and R both are null, nothing we have to print. We'll come back here, go to the right side, and right side we found 7, that is the D, we will print. Then left and right, nothing is there. So in this sequence 1 2 4 5 3 6 we have to print the pre-order traversal. Now how to do this thing in programming, we will check next. So the first solution we will check using recursion. So if we have to recursively traverse this tree, so first thing we have to mention is we will follow the DLR rule, that is first the parent node, then the left side, then the right side. So same manner we will write the recursion function also. So if this is my pre-order traversal program where actually it will accept the root, first I will check if the root is not null, then I will first print the root data, that is the D. Then we will do a recursive function call again to left, then right. So if you look at the recursive tree here, so actually it is also follow the same thing. So suppose 1 is my root node here. So I came to this function, and it is obviously not null, then I print the data. Then I am again calling this function using the root.left, that is 2. Means now the operation will happen on this particular tree, and this is the root now. So when we will come to 2, 2 is not null, we will print the root data, that is 2. Then we will go for 4, and 4 will be our left side. Then after printing 4 here, because we are again traversing the same function, then after some time we will find that this side is null. Then we will come back again and print the right and keep on going. Now we will do the coding and things will be more clear. Now coming to the coding part, I have defined one class called pre-order traversal. And here I have defined a static class which will talk about the tree node. So one particular node is denoted by one data field, one left and right node. So in the main method I have defined the root node and mentioned that is as 1, and then left and right I have assigned as 2 and 3. And then for 2 actually left of left also I have assigned as 4, and left of right is 5, right of left is 6, and right of right is 7. So my whole tree structure is ready. Then I am passing this root node to this pre-order traversal recursion method. So here what I am doing, I am checking for the root node, and if it is not null I am printing the root data, and then I am calling again the same function using root.left and root.right next onwards. So now we will run this program. So it is printing in correct order 1 2 4 5 3 6 7. So this is the way we have to do a pre-order traversal using recursion. Next we will check about how iterative way we can do the same thing. Now we will talk about the iterative approach. So here is the tree. We have to do a pre-order traversal. So in case of pre-order traversal, what we have to do is we have to first print the root node, then we have to go to left and then the left side of this one. So again we have to come back and go to the right side. So if we have to print something, go inside and then we have to come back. So what kind of data structure you think is the best choice here? So obviously we need a stack. So in stack, what we will do is first we will push the root node, that is 1. Then we will just pop it out and print. Before popping out or maybe after popping out, we will push the left and right of this root node. But one thing to mention here we will first push the right side node, then the left one. First you have to push the right node, then the left one. Why? Because when you have to pop again, left side we have to go first, right? So that's why we will push the left side node later. Then only we will get it into the top. So now 3 and 2 is pushed. Now we will pop 2 and print. When I will pop 2, that time we have to again push 4 and 5, but the order we will maintain as 5 and 4, right, then left. First 5, then 4. Then we will pop out 4 and print here. So this part of the things are done. Then what we can see is 4's left and right, nothing is there. Then we can't push anything again in the stack, so we can pop 5 and print. Then everything is done. What is left in stack? That is 3. So we have to come to 3 and we have to pop 3 and print. And this 3's right and left we have to push 7 and then 6. Then we have to pop 6 and print. And for 6 there is no left and right, so nothing to push back in the stack. We have to again pop 7. So after popping 7 we have to print it here and we are done. So now the stack is empty and we have printed all the nodes in a pre-order manner. So now if we talk about the time complexity, so the time complexity involved here for both the process is O of n, because we have traversed all the nodes. And space complexity wise, in recursion also it is forming an internal stack, and here also we are taking one stack where n values we have to store. Not all maybe, but n values we have to store. So the space complexity will be also O of n. So now we will do the programming for iterative approach. So now I will write the method for pre-order traversal using iterative approach. So what first we have to do is we have to check if the root is null or not. If it is null, then we have to print that root is null and we can simply return. If that is not the case, then we have to define a stack of type tree node stack equal to new stack, and we have to push the root first. So first value to push is the root. Then in a while loop we will do the rest of the part. So we will check in the stack, if it is not empty, then we have to pop the item, that is tree node equal to stack dot pop. So you have to pop the item and print the data field, that is node dot data, and we have to give one space to print it in a line. So we will remove the ln part here. Now we have to push the left and right, but before that we have to check if it is not null. So the first thing to remember is we have to first push the right side, then the left. So if node dot right, not equal to null, then we have to push that item. Stack dot push the node dot write. And same thing we have to do for the left part also. So for the left part, what we have to do is node dot left, we have to check if it is not null, then we have to push it in the stack. Now we will just simply run this program to check. So what we can see is 1 2 4 5 3 6 7, same result it is also giving. So this is why we have to do a iterative way we have to traverse.